In this video, we will show you how to check the health of a garment factory by measuring the cost per piece. We will also assess the impact of order quantity and frequent style changeovers on product costing using a problem as a case. So, let's start by discussing, what is cost per piece? Cost per piece is the total cost incurred by a factory for producing a garment. It is a KPI used to monitor profit, loss in order execution. It is highly applicable in factories which are doing job work. In that case, they are paid cost of making, which includes cutting, sewing, finishing, and packing. Trim cost is also included sometimes if the vendor is responsible for ordering trim. The cost per piece for an order is calculated using this formula. This can be formulated as cost per piece equals to cost of making a full order divided by total order quantity. Don't worry, these terms will be clear as we dive deep into the explanation. A prime factor of discussion in case of this calculation is the garment cost components. To calculate the total cost incurred in an order and then calculating cost per piece, you need to know cost components. In this video, we will show the activity-based costing, or ABC, method for calculating cost per garment. First, let's discuss the primary cost components in garment costing. First of all, we have the general cost components, which includes costs like cost of cutting, cost of sewing, cost of finishing, cost of packing, trim cost, and both fixed and variable overhead cost. Then we have the order-specific cost components, which include changeover cost per given time, learning curve and efficiency loss due to it, NSR trainings, testing, quality training, operator hire and training, etc. And at last we have the activity-based costing, or ABC method of cost calculation. This is a much more realistic approach than the above two. Every activity creates a cost, and these costs can be associated directly with the product, customer, or supplier for which the activity is being done. All the factory overheads here is allocated to activity centers like design, MS, merchandising, quality, and distribution. Now, let's walk through an example to see how we actually conduct a cost per piece calculation. We will discuss the first approach with a hypothetical example. Here we have taken cost elements of manufacturing and daily production, considering 25 days in a month. As you can see in this table, in this scenario there is no style changeover, which means order of only one style is taken in this month. We have got our data for daily production, average single allowed minute, efficiency, etc. over here. Now for our calculation purpose, the data required are given here. Remember the formula. Cost per piece equals to cost of making a full order divided by total order quantity. First, let's calculate the cost of making the full order. This can be simple done by adding the total monthly expenses for all these expense heads. We add the individual total monthly expenses of the labor charges, overtime, incentive, and all these available expense heads, and get the sum over here. This is the cost of making the given order per month. Now, we just need the production quantity, which is given here. That production quantity, per line per month, is 63,600 pieces per line per month. Now putting them in the formula, sum of all monthly costs or expenses, which is 6,594,808 rupees, divided by production quantity, per line per month, which is 63,600 pieces per line per month. We get production cost per piece of 103.69 rupees. So, this was the scenario when working with just one style order. Now, if there are multiple orders in the same month, then we have to go for changeovers between the production of each styles. In this second scenario, we will take multiple orders in a month since there are frequent order changes. We have tried to demonstrate the implications of small orders in manufacturing and why there is a need for minimum order quantity. While planning or budgeting, we need to consider losses due to changeover, otherwise plan versus actual will have a huge gap. So, in this scenario we are considering 10 style changeovers in a month. Like the first scenario, we have all the data given here, but due to changeovers there will be change in efficiency after each changeover. So we have to take into account the efficiency after changeovers, including line setting and learning curve, etc. And instead of doing of daily efficiency, we have monthly of efficiency here. Since our expense heads like the labor charges, overtime, incentive, and all these available expense heads didn't change because of changeover, our sum of all monthly costs or expenses remains the same, which is 6,594,808 rupees. If there were some changes, then that would be calculated too. But, due to changeovers between styles, there was change in line efficiency. It is obvious that after each changeover the line lost some time to achieve optimum efficiency. So the production quantity per line per month changed, and now it is 52,622 pieces per line per month. Now putting them in the formula, sum of all monthly costs or expenses, which is 6,594,808 rupees, divided by production quantity per line per month, which is 52,622 pieces per line per month. We get production cost per piece of 125.32 rupees. So, cost per piece has increased from 103.69 rupees to 125.32 rupees with increase in order quantity and styles. This is prominent from these examples that style changeover is a high factor impacting manufacturing cost and productivity in a factory. In a factory, when there are smaller orders, there will be more style changeover. So, you can relate the impact of order volume in garment cost per piece. If you are checking the health of a factory, you can compare the monthly cost per piece for the running orders with the benchmark cost per piece. It would be easier calculating the average cost per piece for a single product category. If you are working with multiple product categories, compare it with cost per standard minutes. Less the cost per piece, better the heat of a factory, and vice versa. Cost per piece and line changeover time need to be closely monitored. Style loading sequence must be planned by production planning and control so that similar styles come one after another. This will reduce the need for new machines and new skills. It will also reduce sudden jump in manpower shortage or abundance.